Hello and welcome to the second part of this tutorial. And before I start with my analysis work, I'm going to change some of the basic settings. I'm going to leave the background color as it is in this case, and I'm going to click instead on the graphics window. I'm going to select by aspect ratio from the drop-down menu, and I'm going to change the aspect ratio value from 1.33 to 2. Click OK. And next time that I navigate to view and I click on clear, we see that a window of aspect ratio 2 is showing up. So if I click on the mesh plot, I can see the ADINA logo, the global axis system, all enclosed in the area where I'm going to be working, which is a box with aspect ratio 2. I'm going to navigate to control, degrees of freedom, and I could leave all 6 degrees of freedom active, but because in this case I will work with solid elements and solid elements do not have rotational degrees of freedom, I'm going to switch this off, which will make my analysis a bit lighter and a bit faster. If I had any beam elements or shells, for instance, then I couldn't do this. I would need to make sure that I have all 6 degrees of freedom active. Next, I'm going to change my analysis type to frequencies and modes, and right next to the analysis type menu, I'm going to click on the analysis options, and I'm going to request 10 modes, and I'm going to request 10 modes be printed too. Click OK, and now we are ready to start with the modeling work. And I will start by defining my geometry. In ADINA, there are 2 ways of defining geometry from ADINA user interface. We can, of course, import geometries from CAD packages, but in ADINA, we can either use the geometry native engine that allows us to define points, lines, surfaces, and volumes, or we can use ADINA Modeler. In this case, we're going to use ADINA Modeler. We're going to start by defining bodies. We're going to add a new block, which will have a dimension vector of 1, 0.3, and 0.025. We click on Save, and that's my plate. See that we can change this parametrically. So if, for instance, we want to display it thicker, we can change that parameter, and the plate updates automatically. We're going to add a couple of additional cylinders that will help me generate some holes. So we're going to add a new cylinder, radius of 0.025 and length of 0.1. I want the axis of the cylinder aligned with the vertical Z direction. And the center position will be at minus 0.4, minus 0.1, and Z can be centered. Click on Save. And now I want the symmetric, so we're going to copy that and reverse the sign of the Y center position. So those are my 2 cylinders, which I can choose to display by colors, and there we go. Those are the 3 bodies, the plate, and the 2 cylinders. Now from the ADINA Modeler menu again, we're going to perform a Boolean operation. We're going to subtract from the target body. Click on the P button, select, and we're going to subtract bodies 2 and 3. Right access double clicking on that blue field, and then right click and finish when I have finished. We're going to make sure that the keep the subtracting bodies option is off, so the cylinders will disappear after performing the subtraction, and that is my hold plate that I'm going to be analyzing. Now that we have a geometry, we can proceed. We're going to apply supports at the inner faces of those 2 holes, and we're going to mesh the plate and give it some properties. So first of all, we're going to navigate to Model, going to rotate and zoom the model a little bit. We're going to click on Apply Fixity. We want all degrees of freedom. There is a default fixity that constrains all degrees of freedom. So we're going to select that one, and it's going to be applied to faces and surfaces. So double click on the blue field, select those two inner faces, right click and finish, and OK. Right, now we want to mesh the plates. First of all, we're going to define a material property by clicking on the material button. We're going to define an elastic isotropic material. We're going to add a new material. The Young's modulus is going to be 200E9. Poisson's ratio is 0.3 and the density is 7850. Note that the density is very important. That is mass density, that is input in the mass per unit volume units, not in weight per unit volume, because otherwise the dynamics response and the properties won't be correct. So this has to be, in this case, kilograms per meter per cubic meter. We click OK and close. And now we're going to go to navigate to meshing, element group, and we're going to add a new element group that will be a 3D solid. It will already be pointing to material 1 that we have just defined, so that's correct, and we can click OK. Before we mesh, we need to define some mesh density, and here the strategy will be to define mesh density for the top surface of this body, the top face, and then we will extrude it, or we will propagate it along the length of the thickness with a number of divisions. So we're going to, under the meshing menu, go to the mesh density tab, click on subdivide faces. We're going to specify a length of 0.01, double click on the blue field, select that face, right click and finish, and click OK. We can ignore the warning message in this case. And now we're going to the Create Mesh tab, and instead of clicking on the Mesh Bodies button, we're going to click on the arrow right under it and go to Lofted Body. We're going to double click on the blue field, select the face, right click, and finish. And we're going to have 3 elements through the thickness. We click OK, and that has actually meshed our plate. So if we click here on Hidden, we see that we have our plate fully meshed with 3 elements through the thickness. Right, so we are now ready to solve this analysis. So I'm going to save my model, navigate to Solution, Data File and Run, and we're going to solve the analysis. It's going to take very little to obtain this 10 modes of vibration. We can click OK and close, and we are now ready to change to the post-processing screen and open my results. So I'm going to navigate to the Home menu, open, and select the porthole file, the results that I've just generated. This is the deformed shape for my first mode of vibration. I'm going to choose Shaded View. And here on Results tab, I'm going to click on the undeformed shape as well, the None, so I can better see how the plate responds or how the different modes of vibration are relative to the undeformed shape. We can see the first mode has a frequency of 27.16, which is a simple bending mode as we would expect. I'm going to create a new band plot to see the normalized displacements for each mode of vibration. So I don't do that through displacements, I do that through eigenvector. And here on eigenvector, I can choose to plot any particular displacement component, but we're going to choose the total magnitude. Click OK, and that's giving us the well, the normalized displacements, magnitude. And here on solution, always under the results tab, we can skip, see the different modes and associated frequencies here to the top left of the screen. So this mode is the second bending mode and it has 474 Hertz and so on. Of course, we might be interested to list our frequencies. So we can go to the list menu, to zone, and that will open up my dialog where I can interrogate different results components. So here on the variable to list, we can choose frequencies and modes. We can get eigenvalues, frequencies, and so natural frequencies. So we click, for instance, the frequency and apply, and that is giving us the frequencies for pulse and modes of vibration. So this concludes the second part of this tutorial. I will see you on next ADINA tutorials. Thank you.